Alright kids, we're going to do a little bit of, or a whole lot of factoring practice. You can fast forward, you can rewind, or whatever you need to do in order to get this done. I'm going to only do the easy ones my way. Maybe I'll do a couple of them the hard way and so, but these ones where this leading coefficient is just 1 right here. It makes it rather simple. You're just going to factor this to split up to be x times x. And these have to multiply to positive 3. Well, the only way to multiply to positive 3 is positive 1 times positive 3, or negative 1 times negative 3. Now, if you add these up, this is positive 4 and this is negative 4, and we want the pair that adds up to positive 4. So to finish this off, we're going to need a positive 1 and a positive 3. That's really all there is to it. I know you can do this using the product sum rule, and I'll show you on the next one how the product sum rule works, but it's kind of a pain. First, I'm going to do it my way. I'm going to split the y's up. And in order for the rest to part, I'm going to find 2 ways to multiply to 5, or a way to multiply to 5 that adds up to 6. But it's either a plus 1 plus 5, or negative 1, negative 5. And what I want the ones that adds up to positive 6, so I'm going to use plus 1, plus 5. Now, if you want to use product sum, oops, that's not what I wanted to do. If you want to use product sum, what you need to do is, the product is 1 times 5 or 5, and the sum is 6. So when you rewrite it as y plus, and the two numbers are 1 and 5. Well, those are the two numbers. Why not just put them in? But that's not how product sum works. Keep grabbing that dumb thing. What the heck? What this is. Stupid. So y plus 1y plus 5y plus 5. Oops, this is y squared. So y squared plus 1y plus 5y plus 5. So out of these two, I can take a y out. I'm left with y plus 1. Plus, now these two, I can take a 5. I'm left with y plus 1. So my first set of parentheses is y plus 1. And the second part is y plus 5. But with these easy ones, you already knew those were going to be the two numbers. That's all you had to do. We're finished. Alright, so anytime you have a binomial, it's two items like this. Look to see if they are the difference of perfect squares. And this is x times x, and this is 10 times 10, so the parentheses will look exactly the same. X into x, that gives me my x squared. 10 and 10, because 10 times 10 is 100. Now, because there's nothing in the middle, I need one of them to be plus. Number 4, I'm doing only these my way, because they're the easy way. K and K. Now, because this is plus, I know it's either positive 7 and positive 7, or negative 7 and negative 7. Of course, I could use positive 1 and positive 49, or negative 1 and negative 49. Focus. But I need a pair that adds up to negative 14. And it's this pair right here that adds up to negative 14. So that's negative 7. Negative 7. Again, this is a rather simple one, only because we need a pair that adds up to multiplies to 81. But because it's positive, the signs have to be the same. And this will tell me that the signs are both going to be positive, because they got to multiply to a positive and add up to a positive. And that's just 9 and 9, because 9 times 9 is 51. 9 plus 1 is 18. So I got a binomial. This is z times z. This is 6 times 6, so it's the difference of perfect squares. Very simply, it's going to be z plus 6 to z minus 6. Alright. Since this is a positive, you know that the two sides have to be the same, and they're both going to be positive. Now the way to multiply to x squared is x times x. They have to add up to 8, multiply to 8, multiply, and add, and 8. Alrighty. Now, I haven't had one in a while, but it's negative. Now the only way to multiply to a negative is a positive times a negative, which means one sign has to be positive and one sign has to be negative, not negative 1, so it's negative 1. Just a negative. Okay. Well, the other thing is they have to multiply, they have to add up to a positive 1. Well, that means we're going to have either positive 1 and negative 90, which are really far away, we'll never get a 1, or positive 2 and negative. Wait a second here, these are going to add up to negatives. So what I really need to do is make sure that my larger number is the negative, is the positive. So negative 1 and positive 90. Those add up to 89. Not even close. Negative 2 and positive 45. We're going to be here all day until you get to the easy one, which is negative 9 and positive 10. Those are the two that add up to 90, or excuse me, they multiply to 90 and add up to positive 1. So negative 9, positive 10. Alrighty. There we go. Again, subtraction. Now when everything in the middle is 1, that means you're going to have numbers like 2 and 3, 4 and 5, 6 and 7, 8 and 9. Two numbers right next to each other that when you subtract equal 1. Or if you do it, the larger one's negative, they equal negative 1. So A and A. I know they have to be one positive and one negative. And since they have to add up to a negative 1, I'm going to make the larger one positive, or excuse me, the larger one negative, and the bigger one, or the smaller one positive. And there's the pair right there. They multiply to 42 and add up to negative 1. So the larger one negative. Again, we have a negative. So I'm going to put B and B. Since they have to multiply to a negative, one of them has to be positive, one of them has to be negative. But we have to add up to positive 12, which means the larger one's going to be positive. And they got to multiply, so they got to be 12 away from each other. So I can't pick 1 and 45. You know, the larger one being positive. Those are 44 away from each other, or negative 2. Oh, can't be. Another one is negative 3 and positive 15. How far away are they from each other? 12. We're done. Positive 15, negative 3. 5 and 9 are the only other pair to really pick from, and those don't add up to 12 or subtract 12. Alright, we've done a few like this already. So, we have H and H. This is negative. This is the sign. The most part of the negative is a positive times a negative, And since this is a 1, they have to be like 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You gotta find a pair that multiplies the 56 or 1 away from each other. Well, that's so. I didn't pick 7 and 8. So 7 and 8 are 1 away from each other, and multiply to negative 56. So the larger one has to be negative, since that's a negative. So 8 and 7. And now the next one, they don't have to be 1 away from each other, they have to be 2 away from each other, because the middle number is negative 2, and because they multiply to give you a negative. So, again, the larger one's going to be negative. So J. One's positive, one's negative, because that multiplies to give you a negative value. And if you look at it for a little while, 2 away from each other, I mean, I can pick 4 and 6, 5 and 7, 7, 9, 9 and 11. So the pair that multiplies to 63. There it is right there. There's your pair that multiplies to 63. And they're 2 away from each other. In this case, let's make this negative and positive in order for these to add up to negative 2, which is this number. So, negative 9 and positive 2. Finally to a point where we got to look at these, and I got to remind you that every time you're going to tackle a factoring question, you have to look for a GCF first. In this case, the GCF is 3. When I take a GCF out, anytime you take the GCF out, you can only have one set of parentheses, at least to start. In this case, we're going to be left with x squared minus 25. Now, when you start seeing numbers like 25, in your brain you just think, oh yeah, perfect square. There's a binomial, that's the difference of perfect squares. So we're going to be 3, and then we just got to keep going. X and X, 5 and 5. The difference of perfect squares means 1's plus and 1's minus. Okay, back to an easy one. A. Now they're multiplied with negative 3, which means one's going to be positive, one's going to be negative. They got to add up to a positive, so the larger one's going to be positive. And since 3 is prime, then we're going to multiply with 1 times 3. No, it's going to be 3 and 1. Again, here we go, looking for GCS. In this case, the GCF is 6. I'm left with y squared minus 9. Isn't this y times y right here? And 3 times 3, so we have a binomial. That's the difference of perfect squares. So what I need is y plus 3, y minus 3. GCF here, I can go with a 5. I think that's about it. So I'll take out a 5. I have a binomial, so I'm kind of hoping this is perfect squares. 20 divided by 5 is 4. F squared minus 9. And yes, I have the difference of perfect square. So, 5 what times what gives me 4. Well, that's 2f and 2f. And multiplies to give me negative 9, positive 3, and negative 3. Hopefully we'll start getting some harder ones soon. Alright, this is the one that dear Mr. Yakumahalos decided to ask me about, and then promptly was kind of embarrassed about it. We got to multiply to a negative 14. Well, that means one's going to be plus, one's going to be minus. We got to add up to 13. So, the positive 13. So that means a larger one has to be positive, smaller one negative. Let's take out the GCF here. We're left with s squared plus 2s plus 1. Don't forget the plus 1. Remember with GCS, we have 1 parentheses. That's what I've done though, of course. I'm certain this trinomial can be factored. The only way to multiply by 1 is 1. If they're the same sign, they both have to be positive. So positive 1, positive 1. This one's kind of tricky. Signs are the same, so they both have to be positive. And the way to multiply to positive 36 is positive times positive. And they have to add up to it. And you can do 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Those are all the different ways. Just want the one there to 15, 3 and 12. Alright, GCF again, so take out the 5, we're left with n squared plus 8n plus 16. That's how many times 5 goes into 8. And then I can just factor n and n. Since this is positive, the signs have to be the same, and they both have to be negative. Excuse me, positive. And they have to multiply 16 and add up to 8. 4 and 4. I told you those 1 to 5 and 6 are tough. Alright, so be careful with these. The signs have to be the same. So in this case, they both have to be negative. So negative and negative. And multiply to positive 6. Add up to 5, 3. We're going to take out the GCF 9. I'm left with n squared plus 6n plus 9. And now I have to find two numbers that add up to positive, multiply to positive 9, and add up to positive 6. Well, everything's positive, so I use positive, positive. Of course, it's 3. And then let's do those hard ones. GCF 2, left with d squared minus 81. Minus 2, d plus 9. D minus 9. That's the difference of perfect squares again. And here's 5 and 6 again, just to make you mad. In order to factor it, because this is negative, one of them has to be positive, one of them has to be negative. The only way to multiply to a positive, a negative number. And then the larger one has to be negative. Well, I can use negative 6 and positive 1. Or negative 2 and positive 2, negative 3. Well, this is the pair that adds up to negative 5. So negative 6, positive 1. So this is the difference of perfect squares. And someone might be inclined to just say, oh, okay, that's 2t plus 8, 2t minus 8. But what I really should have done here is take out the GCF first and left with t squared minus 16. If I take out the 4, which is the GCF, I'm left with t squared minus 16, which is also the difference of perfect squares, which is t plus 4, t minus 4. Alright, this one's not bad. G and G. Multiply to give you negative, means one's plus, one's minus. The larger one has to be negative. So 28, it's 4 and negative 7, or 1 and negative 28, or 2 and negative 14. I gotta find a pair that adds up to negative 3. There it is right there. Add up to negative 3, so it's positive 4, negative 7. This one obviously has a GCF. I think we talked about this in class. The GCF was 8. And I'm left with 9g squared minus 16. Notice 9 and 16 are both perfect squares. So this is again the difference of perfect squares. 3g times 3g is 9g squared. 4 times 4 is 16. 1 is plus, 1 is minus. two numbers that multiply to 144 that add up to 144. Or excuse me, multiply to 144 that add up to 24. So that's pretty simple. Plus 12. Plus 12. Gosh, we're still going. And signs have to be the same. They both have to be negative. Negative, negative. There's only one way to multiply the two. This one has a GCF of 4, so I'm left with x squared minus 6x plus 9, which I think we've already factored before. X and x. Multiply to positive 9, so they both have the same sign. Because these need to multiply to positive 9. And that's negative 3. Negative 3. Because this is positive, they have to be the same sign, and they're both going to be positive. H and H. And the easiest way to multiply to 24 is 4 times 3. This one has a GCF root of 13. N squared minus 4n minus plus 52. So 13, not 52. Four. So n minus 2, n minus 2. They're going to have the same sign. It's positive. And add up to negative 4. Good, done. Plus 20. Minus 2. Because different signs and they add up to 16. 225 is actually 15 squared, and 15 plus 15 is negative 30. So 15 is the same. They're both going to be negative. And 15 and 15. Q and Q. The signs are different. One's plus, one's minus. Multiply to negative 18. That's really far away from each other. So you wouldn't want to pick like 8 and 5. You would like to pick something like Q and negative 20, because those add up to 8, negative 18. So positive 2, 20. So you're going to actually have to take out the 15. You're left with a squared plus minus 6a minus plus 9. And I think we've already factored this one. A minus 3, a minus 3. Oh my God, I want to get to the more exciting. Alright, they're only one away from each other, so the side number is going to be like 7, 8, 8, 9, 9, 10, 10, 11, 11, 12. Oops. So, I know that the signs are going to be different. One's going to be positive, one's going to be negative. And the large one has to be negative, and I need the pair that multiplies to negative 110. There it is. Negative 11 and positive 10. Multiply to negative 110, and they add up to negative 1. So we get G, signs are the same. Both are going to be negative. I need to add up to 56. Now that's 8 and 7, and those multiply to 56, and they add up to 15. V squared. So we're going to do V plus 11, V plus multiply to 121, multiply to 121, and add up to 22. This one's kind of tricky. It's just N. And because this is so big, you should know that two numbers have to be kind of far away from each other. It's minus 27. And minus plus 2. Hey, finally we did some harder problem. Finally. there's no GCF here, so I can't take any number out. And the only way to multiply the 2x squared, which I have to split at the beginning of my parentheses, is to get a 2x times an x. That would give me 2x squared. Then I have to come up with a 2. Now, there's no GCF to begin with, correct? And there's only one way to multiply the 2. Positive 1, positive 2. Now, since there's no GCF to begin with, I know I can't put that 2 in there, because that would give me a GCF. Like we talked about in class. If I was to put a plus 2 in here, I could take this 2 out. It would have a GCF. And I do not want to do that. So, I can't put the 2 there, so the only way to put is to put the 1 here and a positive 2 here. Now let's check this. That's 2x squared. Perfect. That's positive 2. Perfect. And these make up the middle, so that's 4x plus x. Hopefully I can make a few A's. Oh, I was going to do that one using product sum. I'll do this one doing both ways. Alright, so there's only one way to multiply the 2x squared. Again, is 2x times x. Now, positive 6 can be multiplied 2 and 3, or 1 and 6. Now, in this case, a lot of kids will pick 1 and 6 because those add up to 7. But actually, that would be the wrong case, because don't forget with hard factoring, one of the numbers has to get multiplied by 2. So I'm going to try these first. Since I'm going to try 2, I know that 2 can't go in this set of parentheses right here. So I'm going to put the positive 2 here, and the positive 3 here. If I do that, there's 4x, and there's 3x, and there's my 7x. So I'm finished. There it is. Now we're going to do this using product sum. So the product equals 2 times 6, which is 12, and the sum equals 7. So what product sum is, you need to pair it, add them to 7, and multiplies the 12, and that would be 3 and 4. So I'm going to rewrite this 2x squared plus 3x plus 4x plus 6. And this one you can take out a 2, you can do an x. And over 2x plus 3. And this one you're left with, oops, this one you're left with plus 2x plus 3. So your final answer is 2x plus 3 and x plus 2. So that's the product sum rule. We'll do a couple more like that. 43. So, my way, I'm going to put 3x into max sum, because that's the only way to split that. Now, I'm going to play with 5. What I want to put 5 in there is maybe 5 and 1. That's 3x. That's 5x. And if I subtract those, I actually get 2x. But I want to make sure this is the positive one. So 5 has to be positive, and the 1 has to be negative. And there's your answer. Now, using the product sum rule, well, to really pass my bedtime, I'm going to multiply. So I get negative 15, and I have to find a way to multiply the negative 15, add the 2, so it's negative 3 and positive 5. So we're going to replace everything, so 3x squared minus 3x plus 3x minus 5. We just have a x in common, that's 3x. Ooh, let's back up the crazy train here. It's 15. Oh, this is 5. 5, negative 3. So I take out a 3x and I'm left with x minus 1. I take out a 5. Crap, I did that wrong again. Take out a positive 5 and left with x minus 1. So your two sets of parentheses are x minus 1, 3x plus 5. Product sum, negative 6. Product sum is 1, so it has to be positive 2 and negative 3. So, let's do it my way first. Boom, 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 boom. So it's going to be 2x and x. There's only one way to multiply 3, 1 and 3, so put a 3 here, and a 1 here just for fun. That's 2x, and that's 3x. And if I subtract those, I get this 1x. I just gotta make sure this one's positive. So this is positive. This is negative. And the way to multiply to that is 2 times negative 3. Those don't add up to the middle, do they? It's negative 2 and positive 3. So we add 2x squared plus 2x squared plus x again plus 2x plus 3x minus 3. Now these I can take out 2. 2 so left with x plus 1 plus 3x minus 1. And I screwed something up here. Oh. Alright, so here's where I screwed up. Let me back up a little bit. This should have been a negative. And this should have been a positive. So it's a negative, which makes this a negative. X minus 1. So my two parentheses, and this is 2x, I should have taken out. So my two parentheses are x minus 1 and 3x minus 1. Oh man, I'm getting tired, kids. 2x plus 3. Alright, I'm going my way. It's just a pain in the x and go there. 7x and x. The easiest way to multiply this would be 3 and negative 4. Let's try that. So positive 3 and negative 4. 3 negative 12. There's your 7x. This is negative 28, and this is positive 3. That adds up to negative 25. I want negative 40. So, how about 6 and 2? So, 7x plus 6, x minus 2. That's 7x squared, that's negative 12. This one gives you negative 14x plus negative 14x, and this is plus 6x. So that really doesn't give me that negative 40. And I think we worked this one out in class. I want to get 40, so I really should have multiplied the 7x times the 6. And then put the minus 2 in. And that's your answer. Ooh. so 2x x. There's only one way to multiply this, is negative 2 and 3, or positive 2 and 3. I can't put the 2 here, so I'm going to put the negative 2 here and the positive 3 here. If I do that, that's positive 3x and negative 4x. So I've got my signs all messed up, because those add up to negative 4. So I really want to make this negative, make this positive. Product sum. Product, they have to multiply to negative 12, and sum they have to multiply to 1. So the two numbers are negative 3 and positive 4. Because those multiplied to negative 12, they add up to 1. So I do 2x squared minus 3x plus 4x minus 6. I group these two together, I take out an x, and that's for 2x minus 3. If I take a 2 out of this, I'm left with 2x minus 3. So my 2 subsequents to 2x minus 3. X plus 2. Let's see, almost. Alright, so 2x and x. 5 and, it's just going to put a 5 and a 3 in, so let me put a 5 here and a 3 in. That's 15. That's 3. Is that going to be 12? That's negative 13. So we're saying that it would be negative, that's not. So let's try it this way. 2x minus 5. X minus 3. Is negative 6 and negative 5. Negative 6x and negative 5x add to negative 11x. Done. Alright. 2x and x. So we have 2 ways to multiply to negative 8, negative 2 and 4, or 2 and negative 4. We'll try. Let's try negative 2 and positive 4. That's positive 12 and negative 2 gives me like 10x. And if we do this product sum, first we have to multiply this 3 times the negative 8, so the product is negative 24, and the sum is 10. And then to figure that out, you're going to multiply two numbers by 4 and 6. Both of which we have to multiply. I don't think those are going to work because one of them has to be negative. So how about negative 10? Negative 12 and positive 2, or positive 12 and negative 2. That's better. So we can do, oops. We're going to do 3x squared minus plus 12x minus 2x minus 8. Take out these two, I can take the 3x out, and I'll put x plus 4 minus 2 x plus 4. What do you probably, I think I'm going to make it good. Alright, this one I'm going to take a 3 out. I'm left with x squared plus 2x plus 1. And it's just x plus 1. X plus 1. Multiply to 1, add it to 2. This one's not quite as easy. We'll both ways, I guess. 5x and x. Just gotta put a 2 and a 3 in. I'll put a 2 here and a 3 here. Both sides are going to be negative. And that gives me negative 10x and negative 3x, which is negative 13x. Quadratic sum, I gotta multiply to positive 30. Add up to negative 13. That's negative 3 and negative 10. So we wrote 5x squared minus 3x minus 10x plus 6. I can take an x out, I'm left with 5x minus 3 plus 2, 5x minus 3. So our two sets of parentheses are 5x minus 3 and x minus 2. 20 left. 2m and m. Oh, gotta go plug this thing in, otherwise we're gonna die soon, and that would make me really, really better hurry. I'm ready. There we go. Oh, maybe that'll wake me up for a few more minutes. Only 9:30, I'm so tired. Okay. We've got it multiplied to positive 20. That's probably going to be 4 and 5. It's either be 4 and 5 or 2 and 10. It's probably not 1 and 20. I'm going to try these, but I can't put the 4 here, so I'm going to put the 4 here. Oh, not positive 4. Signs have to be the same. And it does have to be negative. So negative 4 and negative 5. So that's negative 8 and negative 5, make negative 13. Finished. I'm not doing the rest of these. I'll do some of the composite ones a little bit more. So 3w and w. I gotta multiply by negative 12. So I can use negative 3 and 4, or negative 2 and 6, or negative 1 and 12. Maybe the sentence has changed. So I'll try these. I can't put the 3 in the first one, so I'll put a 3 here and a 4 here. That's 9, and that's 4. That's 9w and 4w. And if I subtract those, I get 5w. So I want the 9 to be the positive, so I'll put 9 here, and negative here. Now for those of you who know product sum, product is negative 36, and the sum is 5. So that would be positive 9 and negative 4, which of course are those two numbers right there. So I get 3w squared plus 9w minus 4w minus 12. Out of these two I can take a 3w, and I'm left with w plus 3 minus 4. Now to take a minus 4 out of both these, I'm left with w plus 3. So my first set of parentheses is 3w minus 4 and w plus 3, which okay. And the way to get to 5p is 5p times p. Those two give me 5p squared. Alright, 24 plus 4 and plus 5. I'm going to try these first. Now I can't put the 5 in the first set of parentheses because it's we have a GCF, so I'm going to try to put the plus 4 here and the plus 5 here. That gives me 25 and 4, that's 29. That's too much, so I'm going to erase that with the media pencil. And I'm going to try 3 and can put those either way I want to. If I put the 8 here and the 3 here, that's 40 and that's 3, so that's not going to give me what I want. If I reverse it and I put the 8 here and the 3 here, I think that's going to give me what I want, maybe? No, that's not. That's 15 and 8. That's 23, not 26. So now I'm down to 2 and 6. Or 1 and 12. Wait, what am I doing wrong? I'm such a moron. You guys probably caught it already. I was kind of screaming, this is not a 5. Positive 6. That gives me 24. Now I put the plus 4 here and the plus 6 here. That's 20. And 6. That's 26. Oh my gosh, it's going to be a long night. 7D and D. We got to multiply the negative 28. So I'm going to use negative 4 and 7 just to see. Can't put the 7 in the first one, so I'll put a plus 7 here and a minus 4 here. That's positive 49. And negative 4. Those add up to actually negative 45. Those add up to positive 45. I want negative. So my signs are a little bit off. I'll just change this to a negative. This to a positive. It makes negative 45. Positive 4. Which adds up to negative 49. Alright, you want product sum? Holy mackerel, what just happened? I don't know what happened to my paper. Oh. I really don't know what just happened. Hopefully I can find it. Hmm. 9:41 a.m. What's this morning? No, that's right here. I literally can't find it. I hate this program sometimes. That is. That isn't even close to being noticed. That's what I'm gonna do. I'll finish them up in just a minute. I'm gonna have to do it in the second video.